Okay. Rational numbers. Rational numbers are represented by Q. We represent them by Q. Now, which numbers are rational numbers? First of all, keep in mind your integers are also rational numbers. If I will go to the definition of the rational numbers here, I can say whenever you divide two integers, like rational numbers can be of this form, a over b form, where a is an integer, b is an integer, but the denominator should never be 0. Then I will say the number is a rational number. But it's a definition that you might not understand right now. So I will explain you in the simple words. In simple words, you can say when you divide two integers, we get a rational number. Like what is A? A is an integer, B is an integer. When we divide two integers, we get a rational number. But as I'm saying, it's not that simple. We need to go in a little bit detail to understand that. What is that detail? Point number one is you have to remember all integers natural numbers, because you know all natural are also integers as well. Okay, all integers natural are whole numbers. Are rational also. We can say they are rational also. It means 1, 2, 3, 4, 5. These are integer, whole number, rational numbers. They are all. Okay. But in rational numbers, you have fraction and decimal also. What about the decimal? These are non-decimal numbers. These all are non-decimal. What about the decimal? Okay. Second point, I will go for that. Decimal numbers, sorry, decimal numbers maybe in rational. For rational, I will just write the word q. Opposite word of rational is irrational, keep in mind. Q, and that is represented by q dash. So I can say decimal numbers may be rational or irrational. I can say either they will be rational or irrational. They can be one of them, either rational or irrational. Okay, when they will be rational, when they will be irrational. For that, we need to understand few terms. Okay, let's see. I'm writing one example here. Okay, let's take another example. Okay, if you look at these all are decimal numbers, but there are certain differences in them. First of all, look at this one. This like example number one, example number two, three, and four. I took four examples here. Okay, in the first example, you can see after the decimal, it is only one digit. It is only one digit, and it stops. No more digits are there. I will say it is a terminating decimal. It's a terminating decimal. Okay, what about this one? It is decimal, but you can see it is not terminating. It's going on, going on, going on. It will never finish. So for that, we use the word non-terminating. Okay. What about this one? Oh, sorry, I should write for this also dot dot dot. This is also non-terminating. because it's not ending. This is also non-terminating. Okay, this is terminating. And in case if I take another example, I can say, okay, 5.75, it ended. It's not showing any dot dot. Or most probably sometime with your calculator, when you take any value, let me take here, for example, 1 divided by 3. If I change it into decimal, or I'm sorry, my calculator right now is in the limited mode. And yeah, right now you can see your calculator is showing that one. Hmm? Your calculator is showing 0.3333. It doesn't mean it finish. It means it will never finish, because calculator has certain limitations. It's going on, going on, going on. It's not finishing. But in case if you write 5 divided by 2, that is giving you 2.5. It finished. It ended. But 1 divided by, if it give, it means it is not ending. Or if one more time you press this SND button, that will give you 0.3333. It means it is non-terminating. Okay, so don't get confused with the calculator. So we can say here, this is also non-terminating, but this one is terminating. Now, in terminating and non-terminating, keep in mind, terminating are always rational. If the decimal is terminating decimal, it is rational. So here, one note, remember, as I said to you, decimal may be rational, may not be rational. Which decimal will be rational? Terminating decimal will be rational. But before going to that, I have one more point to say. In the non-terminating, like this is non-terminating, non-terminating, non-terminating. There are two further categories. What are these categories? Category number one is, if you see, once a number start repeating, it keep repeating, such decimal we say are recurring. Mean which is repeating, we call it recurring. Occurring again and again, again and again, that is recurring. Okay, but in this case you can see 8071456. It's not recurring. I will say it's non-recurring. This one is also recurring because 252525 is repeating, so I will say it is recurring. Okay, so in simple, if I make a sketch, the sketch would be like that. I will come back to this one again, but right now I need to draw a sketch here. The sketch is like that. Your decimal can be terminating or can be non-terminating. Okay, among the non-terminating, there are further two types. Non-terminating can be recurring, or we can see call them repeating. Okay, in bracket I'll write repeating, or they can be non-recurring. Mean non-repeating, not repeating. I always try to keep the language as simple as possible. Now, so this is the structure of the decimal that should be in your mind now. For example, let's say I'm writing here 2131317931 so on. Can you call it recurring? Can you call it repeating? Most students get confused with that. No, it is not. It is not. Okay. The reason is, the reason for that one is, it is, okay, these are repeating, but repeating should be like that. For example, if I write 51213, again 213, so on, then I can say it is recurring because three digits are repeating. Then it will be. Otherwise, it will not be. Okay. So now the difference between recurring and non-recurring, hopefully you all understand. Now I will come back here. Keep in mind, in the decimal, terminating are always in Q, mean are rational. When I will write Q, Q mean rational, okay? And Q dash mean irrational. Now, non-terminating, in non-terminating, if it is recurring, mean repeating, then it is rational. But if it is non-recurring, then it is irrational. Now, easily you will be able to identify the difference between rational and irrational. I mean, if I give you any integer, any number, you can recognize whether it is rational or irrational. Okay, let's take an example here. Example is like 5.25. You number 2 is 3 over 7. Number 3 is square root of 3. Number 4 is 503. Number 5 is 2.7198315, so on. Number 6 is 1.375. Now these are certain examples, and I have to identify which one from them are rational, which one from them are irrational. Okay.